Chapter 4, Section 2, Solving Systems of Equations. In our previous section, we did graphing as a way of solving equations. Today, we're going to use algebraic methods. You already know these. The substitution method, so two variables, substitution method, or linear combinations. Let's see what we can do with that. Solve by graphing, just a quick review on this, and see how we could do this algebraically, because these are all set up for linear combination. But we'll try doing it by graphing. Just quickly here, I'll get my, I'll go blue first. When x is 0, y will be correct, and when y is 0, this zeroes out, x will be, sounds right, huh? So let's plot those 2 points. When x is 0, y is 1, that's our y-intercept. When x is negative 2, that's our x-intercept. And there's our line. I'll graph that in just a moment. Now we'll try this one. When x is 0, y will be 4. And when y is 0, x will be 4 as well. All right, so here's my y-intercept. Notice I haven't written anything on the scale. It's probably better if I did. I could say, okay, this is my y-axis, this is my x-axis, this is at 5, and this is at 5. Okay, so back to this. At 4, y is 0. So there's my 2 lines. And I'm going to actually do a straight line. I'm going to do my blue line first. Yes, blue, blue, blue. Okay. I'm going to try drawing a line here. And what I do, I try to get that slope correct. And then I can move it into position. Pretty good. And then we'll change the color on our line to green. And I'll try to draw that just where it should be. All right, actually looks pretty good. So it's intersecting right there. I'm going to estimate what that point that they share is. I think it's at x equals 2 and y equals 2. So this is my solution, at least I think it is. How can I check it? I put it back into both these equations. I'm going to put in the x and the y coordinates and see if the equation remains true. I do it for both of these. Oh, no. I want to put the parentheses in. Equals 20. Let's see if they will work. That's going to be easy. I don't even have to think about which is the x and which is the y because they're both the same. So my x's go here, my y's go here, and I end up with 6 minus 12 equals negative 6. That's true. And then 10 plus 10 equals 20. That's true. So I have verified the point that I found by graphing. Let's move along to doing this algebraically. Here I have equation 1 and equation 2. I'm only naming them so it make it easier for us to talk about them. To add these two together. If I add them together right now, I am not going to eliminate x or y. I'd come closest to eliminating y, though. I'd be down to just one y. This would have become 3x. My goal is to eliminate one variable. This is always your goal, whether you're doing it by linear combination or by substitution, is to eliminate one of the variables. So we're going to add equations 1 and 2, but first I have to transform one of them. Equation 1 still looks good. 2x plus 2y equals 8. This one, if I were to multiply equation 2 by 2, I would have 2x minus 2y equals 4. Now, when I add these, now we know that in linear combination you can do subtraction too. If I were going to do subtraction, I'd end up eliminating my x. I stay away from approaching it that way just because we can get tripped up when we're trying to subtract negatives, especially if you're in a rush, which you might be on a test. So this is 4x. This becomes 0, eliminating it just as we wanted. My x is obviously 3. Now I've got my 3, but my solution needs to have a y as well. So what am I going to do for that? I'm going to come back in over here, put my x into equation 2, 3 minus y equals 2, and solve that. I'll end up with, let's see, I'm going to add y to both sides because I know I want y to be positive. Then I'll have 3 equals y plus 2. I'm going to keep going with that. I subtract 2 from both sides, y equals 1. Okay, now I have my solution. Let's take a look at this. This is just a method of doing what we just... The solution is... Now, if I had followed my own directions, one would think, huh? If I'd followed my own directions, I would have solved this by graphing. I actually am going to do that. If I solve by graphing, say I zero this, I get x is 0. When x is 0, so this is zeroed, y is 4. And when y is 0, x is 4. I'll graph those. I have a y-intercept of 4 and an x-intercept of 4. And in this one, when x is 0, y is negative 2. And when y is 0, x is 2. So I'll graph those. So my y-intercept on this one is negative 2. My x-intercept is 2. I draw a line. Let's see what I get. I think it's going to be a green line, yes. This smartboard usually remembers where it was. Okay, so there's my green line. And I did do it straight. I'm trying to demonstrate what good graphing practice would be. If it only let me grab this line. And then I'm going to do this line also in blue. Blue. Okay. Let's see what this looks like. So if I had done it the way I had laid it out, we would have started out knowing that the graph appeared to have a solution at x equals 3 and y equals 1, which is what we arrived at here. We oh, I'm glad we didn't do this, because as I review it, wouldn't have worked that well. Equation number 2 needs to be multiplied by 2 and then added together. This is the linear combination method. Linear combo. Sounds like a cafeteria special. And this one, we know what this method is. This is substitution method. We could have tried that as well. Oh, I'm afraid I'm getting carried away. I feel like I better try that. You know, all of these methods work for this particular problem. Because I can easily solve for x here, couldn't I? In fact, I did. I did when I did this. X equals y plus 2. And now I substitute that into equation number 1. Equation number 1, my x is multiplied by 2 right here. Okay, let's talk about x. 2 times x plus 2 times y equals 8. And this is equal to x, so I'm going to put it in here, right in here. Now I'm going to use what I know about order of operations and so forth. This is going to distribute, so I'll have 2y plus 4 plus 2y equals 8. I'm going to combine like terms. It all matters, doesn't it? Everything you've learned before is coming into play here. And I'll have 4y plus 4 equals 8. We subtract 4 from both sides. 4y equals 4. I get a y equals 1. So then when I'm thinking about what my solution is, I've got my y. Now I have to figure out my x, and I'm going to go back to the other equation. I could use either one of them, but I'm using the other one because look, it's less complicated. So this is x minus a positive 1 equals 2. I add 1 to both sides, x equals 3. So there, I've solved that in all three methods. I mean, haven't we pretty much gone through the whole lesson already? And we're only 16 minutes in. Plus, we had review of graphing. Excellent. Okay, combine to eliminate one variable. Here's another one, solve using substitution. All right, if I want to combine these, I have a problem in that I can't eliminate a variable by combining them right now. If I try combining them right now, I'll get 20x and 31y, failing to eliminate a variable. So let's try something different. Suppose I try eliminating y. I'm going to get rid of my y. So what do I need to multiply this whole thing by? A 32. I'm planning to add. So if this is negative 32 and this is positive 32, those will zero when I add. Okay, so everything here by 32. I'm going to rewrite it down here. So I'll have 32x minus 32y equals, if I multiply 32 by 4, let's see, I get 8, 128, don't I? Okay, so now I'm going to add these, and this will give me how many x? 51 is what I see. 0y, success, and I add these, I get 4, 1, right? 11 carry, yeah, 241. Now, I don't really know how that simplifies. 241 divided by 51 is what my x is equal to. I'm thinking I wouldn't give a weird answer like that, would I? And then I would have to go on. I think I did. I think I did. And in defense of myself, I didn't actually intend to go ahead and solve them, just talk about which one why this one made more sense to do linear combination, and this one made more sense to do substitution. So I've got a y, and I should figure it out. On this one, substitution looks like a smart way to do it because it's already solved for y. So I can say 6x plus my y, and I'm just going to pop that down in there, is equal to 7. So in the end here, I'll have x equals something. I'm not going to figure out what it is right now. And then I'll have to go on and figure y. Same true here. I have to go on and figure y. Row equivalent operations that we can use when using the linear combination method. Maybe you're wondering, okay, what are the things I can do without changing the truth of the equation? Well, you can multiply, in linear combination, you can multiply any of the equations by a constant. Sometimes you have to multiply each equation by a different constant. You can exchange two rows. You can make the equation 1, you can move it down into the second position and vice versa. You can add a multiple of one row to another row, which is what we did here. So those are the row equivalent operations. Those are operations you can use when solving by linear combination. This one we're not going to solve. We're going to rush through this, going for the kernel of what is important here. If we are going to solve these by linear combination, what multiplier would you use, and on which equation? Now you and I may come to different decisions about this, and we may both have good ideas. How do we know if we had a good idea? When we combine these, when we add them together, do we eliminate a variable? If the answer is yes, that was a good multiplier. In my case here, my answer would be multiply this by -2. In this way, I can eliminate my x. Let's look at this one. I'm always looking for the least amount of work and the solution that has the least hazards in it, the fewer hazards. This one. Oh, this one, I think I would multiply this by 4. Now, why did I choose that? Well, I noticed that 3 is a factor of 12, so I wouldn't have to do anything too complicated. I also noticed that this is already a negative, while this is a plus, allowing me to add without having to do any more sign changing. Up here I had to do sign changing. Now, in my third one, I'm not so lucky, am I? Oh dear. Yeah, I'm going to have to multiply both of them by something. And I do want to keep it as simple as possible, so that means I'm staying away from the 13 and 11 associated with y. And I'm going to work with x again. I'll multiply this by 3 and this by -2. That'll give a positive 6x, a negative 6x, so that when I add them together, I'm eliminating a variable. Okay, let's practice that. All right, we already talked about what we do with this one, or I did talk about what I would do with this. Oh no, not this one. This is different. This one's already good, all ready to go. I didn't have to multiply by anything. So I'm just going to add these together. 8x, this zeros, 32. I get x equals 4. And I have to figure out what my y is. All right, so I've got my 4, and I'm going to figure out what my y is. I'm going to take the simplest equation to do that in, so I'm going to say 3, and my x, when my x is 4, what will my y be? Well, I get -2y equals, I'm going to subtract 12 from both sides. I have -10. So my y is equal to 5. There's my solution. Let's try this one. This one looks like I could manage to eliminate my x by multiplying by a -2. That would give me 4x plus 5y. I'm not doing anything to equation 1. I'm just copying it down as it is. This I'm going to multiply every term by -2. So I'm -4x, -6y equals -26. Now I'm lined up to eliminate my x's. True? That will zero out. I'll be left with a -1y equals -3. So in this case, let's see, I've got my y is a +3. I have to figure out what my x is. So 2x plus 3 times 3, remember my y is a 3, equals 13. I subtract 9 from both sides. 2x equals 4. X equals 2. Now I have my answer. Let's try this one. This one I don't have such a simple way to do it. But, should I go for the 4 and 5 or the 3 and the 7? I think I'll go for the 4 and 5. So that means to eliminate my x, which is what I'm going for, I'm going to multiply this by 5 and this by -4. And that will recreate these as 20x plus 15y equals, now if it were 5 times 20, it'd be 100. It's 5 less than that, so it's 95. And I'm going to multiply this. I get a negative 20x, which is what I was aiming for, isn't it? A negative 28y, and some big number here, negative 160. All right, I add those together. My x's disappear. That's good. And I get a negative 13y equals a negative 65? Did I do my math right? If I divide both of these by a negative 13, I'll get a positive something. How many times will 13 go into 65? 5 times. Oh, works out a lot better than I thought it was going to. So I've got an answer here that includes a y of 5. Now what is my x? I'm going to use this first equation. Looks easier to use. 4x plus 3 times y, which would be 15, equals 19. 4x equals 4. How sweet! So my x is 1. Oh no, number 4 has decimals? No, I hate them. All right. I'm going to, let's see. Does this look like anything I've seen before? Not really. I'm just going to start by multiplying everything through. I want to clear the decimals. I'm going to add an additional step here and just multiply everything through by 10 to clear the decimals. Then I can deal with this without having to think about decimals. Decimals are just a way to get tripped up. Now I wouldn't do this if I had big numbers, but these are small numbers and they're going to look a lot better once I eliminate those decimals. All right, so starting from here, I think, let's change colors. I will multiply this by 3, and you tell me on this one. All right. 6x minus 15y equals 6. On this one, negative 6x minus 14y equals negative, wow, 64. It's a biggie. Now I'm going to combine these. I eliminate my x just as I wanted to. I get this strange number of y's and an equally strange number on this side. But this is going to work out nicely. When I divide a negative by a negative, I get a positive, and it actually goes in there twice. Now, I am going to go back to, I think, this equation here. I can use any one of these. This one, this one, this one, or this one. And to me, this one looks easiest. So I'm going to say 2x minus 5 times 2 equals 2. So it's going to be 2x equals 12. I think I've got my point. Whoa, have we done a lot of work here. Now, I didn't do too much demonstration of substitution. Why not? That's right. You already know how to do that. I'm not going to waste your time with it.